Okay, hello, this is video 6.1, operations of functions. So most of this should be just a review to you guys. So let's look at what we have here on our video notes. So we have our objectives, which are to find all the four operations, sum, difference, product, and quotient of functions, and then we're going to find the composition of them. Okay, so those are our objectives. Our only vocabulary that's going to be new is the composition of functions. And it really isn't new because we've done those before. So let's just look at the basic operations. So we have four operations: addition, subtraction, multiplication. So they can be written two ways. F plus g of x equals f of x plus g of x. And then you have the subtraction, you have the multiplication, and then you have the division. However, remember, we can't have 0 in the denominator, so if we have a variable, we have to list a restriction. So here's an example. So they tell you f of x, remember these are just given names, that's why we have f of f and g of x. F of x equals 2x, and g of x equals negative x plus 5. So if I wanted to add them, I can do them separately. So f of x, which is 2 of x, plus negative x plus 5 equals x plus 5. Same thing with subtraction. However, you're subtracting a binomial, so you have to distribute that negative through, so that becomes 2x plus x minus 5, which gives you 3x minus 5. They just don't show you all the work. And then multiplication, we're just multiplying, we're distributing, correct? And then division, we're not going to divide it, we're just going to simplify and then find any restrictions. So let's look at example 1. Example 1 gives us x squared minus 4 as f of x, and g of x equals 2x plus 1. Let me extend this and move this over. Okay, so basically we're saying f of x plus g of x equals, so what is f of x? F of x is x squared minus 4. I'm going to leave it in parentheses. And then we're adding what is g of x. And g of x is 2x plus 1. So now we just simplify by simplifying expressions, knowing order of operations. Because it's a plus, it doesn't affect anything inside this parentheses. And now we just have to remember to combine like terms. Okay, so this is a quadratic, so the domain is going to be all reals, and the range is going to be y greater than or equal to negative 4. How did I find that? So remember, I have to find the vertex. And once I find the vertex, then I know it's going to open up. So this is going to be your range, whatever y is going up. And this happens to be, I think, I forget what the x is, but the y is negative 4. So we can't forget how to define the vertex of a quadratic. Or you can put in your calculator and find the minimum, because we know it's going to have the minimum. Now let's look at b. It's f minus g. So we're going to do f of x minus g of x. Again, we just find f of x, which is x squared minus 4, minus, parentheses, what is g of x? 2x plus 1. So I can drop these parentheses because it's just a positive 1 outside. I have to distribute this negative, so minus 2x minus 1, and then you have x squared minus 2x minus 5. Again, that domain is all reals, and the range is y greater than or equal to negative 6. So the domain and range of an addition or subtraction is whatever the domain and range of the composition is. All right, so pauses, do guided practice 1A and 1B. All right, so now we're going to do example 2, which is multiplying and dividing. So they want us to do f point g of x, which is the same thing as f of x times g of x. So what is f of x? It's going to be x squared plus 7x plus 12 times g of x, which is 3x minus 4. So remember, I said you can do it this way, or you can do the distribution. I'm going to do it this way. So we get 3x cubed plus 21x squared plus 36x. Now I'm going to do -4, so -4x squared minus 28x minus 48. Then I'm just going to add my two polynomials, so I get plus 17x squared plus 8x minus 48. Okay, so the domain is all real numbers. It's a polynomial, and the range is also all real numbers because it's a polynomial. So let's do FB, which is f over g of x. And to me, it's easier if you say, well, that just means f of x divided by g of x. So now I can just substitute. What is f of x? So f of x is x squared plus 7x plus 12. And g of x is 3x minus 4. However, I have a variable, so I have to find out when does that equal 0 at x equal 4/3. Because when x is 4/3, that's going to make this 0, which will make it undefined. So x cannot equal that. So that's the restriction on the domain. And there's no restriction on the range because they're just polynomials. All right? So pause this. So that's all you're doing is you're rewriting it, you're substituting the functions. And if this was factorable and it equal to 3x minus 4, then you can simplify, but you can't simplify, so we're not going to divide. So in compositions, when we're multiplying or dividing, we leave it, we simplify, we reduce it, but we leave it in this form. Okay, so that's the easy part. So other than division, there is no restrictions unless you have square roots. Okay? All right, so the next section is example 3, which is compositions. So if you look at the third page of your video notes, you'll see the little key concept box, which is really important here. All right, so suppose that f and g are both functions such that the range of g, so whatever the range of g of x is a subset, meaning it's in the domain of f. The composition fog can be written this way. All right, so we have to remember, it's really important to know that fog and golf are not equal. So basically what they're saying, if you have g of x, this is fog, so you start with g of x. Whatever that domain is, you get the range of g, and that range now becomes the domain. You put that into f of x, so that's the domain of x, and then you get your range out of there. So it sounds a little confusing, so let's just do one. Now, the domain and range of the composition is not the same as the domain and range of the 4 operations: addition, subtraction, multiplication, and division. It's slightly different. We're not going to go into that. I might go into it in class and explain it. But here, what I want you to be concerned with, it says find fog and golf. So we want to find first fog. Okay, so another way of writing this is, remember, it goes from left to right of g of x. And we did this with numbers. So we're first going to find g of each one of these, of the x, its domain. So g of 8 is going to equal to what? 15. So we're going to find f of 15. So remember, it becomes the domain of f. And so f of 15, we go to f, is 11. And then we're going to do g of, so we're going to do each one of these x's, 8, 5, 10, and 9. So g of 5 gives us 1. So we're going to do f of 1, which gives us 8. Then we're going to do g of, what's the next g? So these are all the x. There's 4 coordinates, so 4 x's. So g of 10, and we look at that equals 2, because g of is just a fancy word for y. So y is 14. So now we're going to find f of 14, because it's the range of g, but now becomes the domain of f. So where's f of 14? What is y when f is 14? It's 9. Okay, and then we have one more, g of 9 equals f of 0, which equals 13. So now fog is equal, this is written as fog or f of g of x. You can read it either way. It's going to be 8, 11, 5, 8, 10, 9, and 9, 13. That is fog. How did I get that? Input, final output. Input, final output. Input, final output. Input, final output. Okay? Now, they want you to state the domain and range. Well, the domain's going to be, is simply going to be all of the x's, and the range is going to be the y's. Okay, but like I said, we're not going to really talk about it. So all I care is that you know how to do fog and golf of coordinates. So let's do the golf part of it. So g of x, so which that says g of f of x. So we start the process again. So we start with f of x. So what are the coordinates? They are 1, right? So we do f of 1. So if you go to the coordinates, when f is 1, y is 8. So now we're going to do g of 8. We look, when g is 8, the y is 15. All right, so this is a 1. So the next one is f of 0. It's going to give us 13. So I'm going to do g of 13. And if I go over to g, there is no x coordinate of g that's 13. So this one is undefined. So part or some of the problem can be undefined. So the next f or x of g of x, of f of x is 15. So I'm going to do f of 15, and I get 11. So I'm going to do g of 11. So I go to g, there is no x with 11, so this one is also undefined. And then I go to f of 14, which equals g of 9. If I go to 9, I get 0. So in this one, only 2 of them are defined. So golf and fog may or may not be defined. One of them may be defined and the other one may not, or parts of it. So here, you would say that golf is equal to 1, 15, oh, here, 1, 15, and 14, 0. All right, and again, we're not going to be, the book will ask you to state the domain and range. I'm not, until after I teach it to you on the next class period. So now let's look at B. So these are with just coordinates, which we're not used to doing. But this is, if you look at B, this is what we're used to doing. So they give us f of x equals 2a minus 5 and g of x equal 4a. So the first thing I want to do is I want to find fog of x. So again, if you write it this way, then it becomes a little bit easier. So we start with the inside order of operation, g of x. So g of x equal to 4a. Now I want to do f of g of x. So I'm going to put this into this. So 2 times 4a minus 5. Then I just simplify this expression. So 8 A minus 5. Okay, now to do Goff, I do the opposite. So I start with f of x. So remember, this is g of f of x. So f of x equal to a minus 5. Now if I want to do g of f of x, I'm putting this into here. So 4 times what? A. So a is going to be what? 2a minus 5. Now you just simplify 8a minus 20. Okay, so you see these are both linear. So the domain and range, according to the book, it's going to be all real numbers. However, it's a little more complicated than that. So right now, this is all that I'm concerned that you know how to do Fogg and Goff, and we'll talk about the domain and range of compositions. All right, do guided practice 3A and 3B. Now, why do we use this? We use this in real world situations, okay? And it's important to note, again, that Fogg and Goff may not necessarily be equal. So let's look at real world example 4. It says a new car dealer is discounting all new cars by 12%. At the same time, the manufacturer is offering a $1,500 rebate on all new cars. Mr. Navarro is buying a car that is priced at $24,500. Will the final price be lower if the discount is applied before the rebate or if the rebate is applied before the discount? So they need us to do Fogg and Goff, right? So first we have to set up our problem. So we're going to let X be the original price. Okay? And then we're going to say D of X, which is just Y, fancy words, is going to be what? The price of the car after the discount. And then we're going to let R of X be the price of the car after the rebate. Okay, so let's see, what is D of X? So D of X is going to be what? After the discount, so it's going to be what? The original price, X, minus the discount is what? 12% off, so 0.12 of X. Yes? That would be the discounted amount. And R of X is going to equal to the original price minus the rebate of $1,500. So those are my two equations. So if I do rod of X, just like Fogg or Goff, then really what I'm saying is I do R of D of X. So what's going to go first? The discount and then the rebate. And then if I do DOR of X, then I'm saying D of R of X, which means I do the rebate first, find out how much the car is minus the rebate, and then I take the discount off that amount. All right, so let's put these in. So basically we're doing R of D of the price of the car that he's buying is $24,500. I wish mine cost that much. That's pretty cheap. All right, so first thing we're going to do is we're going to do D of 24,500. So we're putting this into 24,500 minus 0.12 times 24,500, which we get $21,560. Okay. Now we have to do R of 21,500 because now we have to do the rebate. Yes. And that's going to be what? 21,560 minus 1,500. When you subtract that, we get $20,060 is what his cost is if he does discount first and then the rebate. So let's do the opposite. So let's do the rebate first and then the opposite. So we need to do R of the price of the car. We put it in there, we get 24,500 minus 1,500, and we get 23,000. So now we need to take the discount of 23,000, which is 23,000, minus 0.12 of 23,000. I'm not writing that out, I'm just going to put the value of that, which gives us 20,240, I think. I can't read my handwriting. All right, so this is what he's going to pay for his car if he does the rebate first and then the discount, and this is what he's going to pay if he does the discount first and this and the rebate. So which way will he get a better rate, a better price, a lower price if he does the discount first? All right, stop this, do the guided practice, and we'll see you in class.